Hello everyone, this is Anishu, and in this video I'll be explaining you about the GPIO basics of the Raspberry Pi. Coming to the circuit diagram that I have used to make this video, I have basically used a Raspberry Pi 4 and an LED and connected the ground pin of the LED to the ground pin of the Raspberry Pi, and also I have connected to the GPIO pin of the Raspberry Pi to the VCC pin of the LED. Now coming to the software side of things, first of all, in the desktop or anywhere else, create a folder that will contain the file for the code. As you can see, I have created a folder named nano method as the destination for my file. Now open the terminal and reach the destination of the created file using cd commands. Now, after reaching the destination, type the command nano programrame.py to create a file using nano text editor. This will open a field where you can write your code. After that, enter the required code. I already made the code through Genie method, so I'll just copy and paste it here. Now, coming to the code explanation itself, in the first line, we are importing the GPIO library, which allows us to control the Raspberry Pi's GPIO pins from Python. In the second line, we are importing the time library to keep in check of the time. In the third line, we are basically setting the GPIO pins to GPIO board. In this mode, we reference the GPIO pins by their physical pin numbers on the Raspberry Pi board. Alternatively, you can use GPIO BCM mode to reference pins by their Broadcom SoC channels. In the next line, we are setting the LED pin to GPIO out, which tells the Raspberry Pi that you intend to control this pin's voltage to turn the LED on and off. Finally, in the try block, which catches exceptions and sets the infinite loop to continuously control the LED. The GPIO output which sets the LED pin to high voltage level. Next, the time sleep which introduces a 0.25 seconds delay to keep the LED on for a quarter of a second. After that, the GPIO output sets the LED pin to low voltage level, which again introduces a 0.25 seconds delay to keep the LED off for a quarter of a second. After that, the loop continues indefinitely until it is interrupted by a keyboard interrupt, that is Ctrl+C. When the keyboard interrupt is detected, the script reaches the accept keyboard interrupt block and it performs the GPIO cleanup. This function cleans up the GPIO configuration and releases the resources, ensuring a clean exit. Finally, after that, simply close and exit the terminal and enter the command to run the code as you can see in the screen. Here is the demo for the code in working.